A humanoid robot just conquered rough terrain completely blind. No cameras, no vision, only raw algorithms, shattering what we thought was possible. This is just one example of how robots are mastering lifelike movements, with breakthroughs redefining industries and pushing the boundaries of technology. The world of robotics is evolving faster than ever. Let's dive into the future. Optimus has taken a bold step forward, literally, into a realm of advanced robotics. It's not just about walking or catching a tennis ball anymore. Recently, Tesla revealed a video of Optimus navigating uneven terrain, including grassy slopes and loose soil, in what could only be described as an unpredictable outdoor experiment. And here's where it gets really interesting. Optimus was essentially blind during this test. That's right, no camera input was used. Instead, it relied entirely on an experimental algorithm to adapt its steps to the terrain. It stumbled at one point but managed to regain balance, showing not just functionality but resilience. This is just a glimpse of what Tesla envisions for Optimus, as they plan to integrate advanced computer vision soon. Once that happens, imagine the possibilities for robots navigating construction sites or disaster zones, where every step could be a challenge. And speaking of challenges, think about the robot's ability to adapt. Optimus is being trained not just to walk, but to walk with purpose, choosing its steps, maintaining balance, and learning from mistakes. Developers are working on making its gait smoother and more natural, especially on uneven surfaces. But they're not stopping there. Optimus is also being programmed to minimize danger during inevitable falls, and this might blow your mind. It's learning to pick itself back up. Picture this, a robot capable of navigating a cluttered warehouse, tripping over a stray box, and then standing back up to continue its task. It's a vision of robots working seamlessly alongside humans in complex environments. But here's the question: how far are we from trusting robots to handle these challenges without human intervention? Now let's shift gears to Figure 02. This robot isn't just a technical marvel, it's practically redefining what a humanoid should look and act like. If you've seen it in action, you'll know it looks like it's been plucked straight out of a futuristic sci-fi film. Sleek lines, soft stops on the joints for smoother motion, and a fabric skin on its neck that moves naturally. These aren't just design choices, they're deliberate efforts to make these robots less intimidating and more relatable. But don't let its looks fool you. Underneath that polished exterior lies some serious engineering muscle. Figure 02 has been making headlines not just for its appearance but for its practical applications. The robot is already being tested at BMW's Spartanburg manufacturing plant. Why? Because it's not just about looking good, it's about getting the job done. Figure 02 has been performing data collection and use case training in an industrial setting, showing that it's capable of contributing to real-world workflows. Its runtime of 5 hours per charge might not sound groundbreaking at first, but when you consider the efficiency of its 2.25 kilowatt per hour battery, it's clear this robot is built for endurance. What makes it even more impressive is its walking gait, controlled by a model predictive system that calculates each step with precision, ensuring stability and fluidity. Imagine robots like this navigating crowded warehouses, lifting heavy loads, and working tirelessly alongside humans. How long before robots like this redefine the boundaries of human-robot teamwork in industries we once thought were solely human domains? But Figure 02's adaptability doesn't stop there. Its swappable legs, yes, legs that can be swapped out for replacements, are a testament to the thoughtfulness behind its design. This innovation isn't just about convenience, it's about revolutionizing revolutionizing how robots are maintained. Instead of taking an entire unit offline for repairs, manufacturers can simply replace components, ensuring minimal downtime. And then there's its modular design. Not only are the legs swappable, but so are the other components like the battery pack. While swapping the battery isn't a quick process yet, the flexibility of this feature hints at a future where robots can be tailored to specific tasks without needing entirely new models. What's even more impressive is how this modularity opens the door to customization across industries. Imagine a factory adapting the same robot for assembly tasks in the morning and heavy lifting in the afternoon, all with a few quick adjustments. It's a design philosophy that prioritizes efficiency, versatility, and long-term usability. And the attention to human-like proportions, narrow shoulders, and a compact frame ensures that Figure 02 fits seamlessly into spaces meant for people. Whether it's weaving through tight industrial aisles or working in homes, this robot is built to function where humans do. Now, hold on to that thought about adaptability, because we need to talk about Clone Alpha. If Figure 02 is rewriting how humanoids work, Clone Alpha is rewriting what they are. This robot mimics human anatomy, down to its synthetic muscles and polymer skeleton. Clone Alpha boasts a stunning 164 points of articulation in its upper body alone, allowing for movements that are so fluid they might make you do a double take. Its hands, wrists, and elbows, for example, each offer 26 degrees of freedom, which is a fancy way of saying it moves in ways that feel eerily lifelike. But the real marvel lies in its artificial muscles, powered by Clone Robotics' myofiber technology. These muscles contract with water pressure, mimicking the way human muscles do. To give you a sense of its strength, a single 0.1 ounce muscle fiber can generate about 2.2 pounds of force and contact 30% of its length in under 50 milliseconds. Now, let's take a step back for a moment and think about the broader implications of these advancements. Robots like Optimus, Figure 02, and Clone Alpha are part of a much larger shift in how we approach robotics. These aren't just tools, they're systems designed to work with and learn from humans. And this learning isn't just theoretical. Take Neo, for example. Developed by 1X Robotics, this humanoid is already capable of tasks like cooking, cleaning, and even playing games. Its muscular anatomy, designed to mimic human strength and gentleness, sets it apart from more rigid, mechanical designs. As Neo moves and performs its tasks, it continuously learns, becoming more efficient over time. Imagine a future where such robots not only assist, but actively adapt to individual needs, blurring the line between machine and partner. Could robots like Neo eventually become indispensable companions in both homes and workplaces? But humanoid robots aren't just sticking to factories or homes anymore. They're making their way into our social spaces too. Take Neo again. Streamers like Kai Cenat are already using it in videos, dancing, interacting, and even helping out in unexpected ways. It's fun to watch, sure, but it's also making robots feel less intimidating and much more approachable. Then there's Kim Kardashian hanging out with Tesla's Optimus. That clip went everywhere. People were fascinated by how natural the robot looked while moving and responding. These moments might seem like just entertainment, but they're actually paving the way for us to see robots as part of our everyday lives. It's all about showing the world that robots aren't just cool, they're useful, even relatable. So, what does this all mean for the future of humanoid robots? Are we on the cusp of seeing them seamlessly integrated into our homes, workplaces, and even public spaces? It's not just a possibility, it's a trajectory. And it's more thrilling than ever. If these mind-blowing robot advancements have you imagining the future, smash that like button and share this video with your fellow tech enthusiasts. What would you want your dream robot to do? Drop your wildest ideas in the comments. Thanks for watching.